All right, so let's get started on this. So we're going to take a look at expressions. By the way, we might get through all of this pretty quickly. It's pretty simple stuff you're going to see. Yesterday I posed a few difficult problems with that first lesson. That first lesson, if you think about it though, it's kind of a really easy lesson. Inequalities, distance on a number line. Now those problems like 36 and 39, those get you to think a little bit more, right? So those are the differences in the types of problems you're going to see this year as opposed to being in a regular math course and an honors math course. So today we're going to look at simplifying expressions. So I'll try to maybe come up with one or two that are a little bit more difficult to challenge you guys along the way as you go through them. So we're going to simplify and then evaluate. What's the difference? Who can help me with some vocab first? Vocab is so important in math. If you want to do well and understand math and understand what people are speaking about, especially in college, if you really want to keep up with your college professors, those who did the best in like advanced science and math courses, they know their terminology. What's the worst thing in the world? When your teacher's talking, you have no idea what a word means that they're saying. So we're going to speak about vocab. So as we go through the year, if you don't know a word, ask what that word means. If I speak about a word specifically, I'm about to, probably write it down if you didn't know it off the top of your head. So let's start with the word evaluate. Evaluate. What does evaluate mean? Mr. Brown. No. I'm glad you said that, George, and it's okay. Because that's the 9 out of 10 student answer is to solve it is evaluate. That's what most people say. It's not solving it. Now, George, you're thinking of solving an equation, and that is correct. You can solve an equation because there's a solution to an equation. But when you evaluate, you're not solving. You're not solving. What are you doing? Somebody help me out. What are you doing? I'm actually glad you brought that up because that's the common answer I get. See, does anybody even know? What does the word evaluate mean? Without seeing it in a problem, isn't it sometimes difficult to understand what the word means? If it was in the instructions and you had the problem in front of you, you probably understood what it meant. Because you can say, oh, they want me to do this because I've seen this problem before. But what does evaluate mean? Tristan, you had a hand. Forget math. What does the word evaluate mean? Forget math. Just the word evaluate. Exactly. So there's I'm going to close the window. There's a water crisis and a drought, and unfortunately, out on the West Coast, they're having trouble with replenishing it. So the engineers look at the situation and they evaluate what's going on. Evaluate, right? You've heard the word. Any idea mathematically what evaluate means? It's in the word. What's the root of evaluate? Come on, use your roots of words. Value. Find the value of something. Evaluate, that's all it means. Find the value. Now again, usually this is in terms of expressions or sometimes functions, but not equations. Equations will not say evaluate, they will say solve or find the solution for equations. Now, expressions, let's write this down also, expressions are simplified usually. Again, you usually simplify expressions, and those don't involve a value for the variable. Again, you can simplify expressions, and those don't involve using a value for the variable. And what do I mean by that? Well, here's an example of it. What does this simplify to? Everybody? Simple as anything. What does it simplify to? 2. Why is it simplified to 2? What happens? The x is canceled. There's an x up top, there's an x down below. If I looked at this expression right here, it would simplify to 2. Agreed? That is what simplification means. That's what we're going to do here. All right? Simplifying algebraic expressions, that's this. Notice, do you see an equal sign anywhere? It is a common misconception for people to write equals. And they write equals this, because you're like, oh, they are equal to each other. And that's true, they are. But if you put an equal sign, so many people then think it's an equation that you're writing. So I happen to use an arrow when I simplify things. When you get to proofs later on, you're going to have left and right-sided proofs, and you'll have equal signs, and you'll carry down simplifications on one side. And that's fine. But when I simplify like this, I use arrows to simplify, just because it's not really an equation. So evaluating algebraic expressions means this. Evaluate when y equals 4. That's what evaluate is referring to. Find the value of. Remember, earlier I told you, evaluate means you're finding the value of something. So by plugging in a 4 for y in these two locations here, you would be finding the value of that expression. So here's the interesting part. You can simplify expressions or evaluate expressions. You can do both of those things. And again, you can solve equations. You can solve equations. Okay? We're going to go on to the problems now, but it's clear. Is it clear that these terms are important? You understand what I mean? Okay, when you see these terms, you should understand what the problem is asking of you. I can't tell you how many people try to solve an expression and they somehow just introduce an equal sign, or they'll write like equals 0 and then they'll solve it. If it's an expression, it means it's going to be simplified or evaluated. It's not going to be solved for. If it's an equation, it's possibly going to be simplified, but it will be also solved for in an equation. So these are important vocab words that I just wrote down, so we don't have to go through all of them. But again, an expression is a symbol or group of symbols. And what does symbol mean? Variable. The words symbol and variable are interchangeable. So it's a variable or group of variables used to represent a number. Value is the number represented by that expression. Now again, you can only evaluate something if you know what the values of those symbols are. If you know y equals 2, you could plug a 2 into the expression and evaluate the expression. Equation, it just means there's an equal sign between two expressions. Put one expression here, put one expression here, put an equal sign, you have an equation. Again, you know these things, but I'm trying to use a little bit more advanced vocabulary in the definitions. Okay? Inequality, again, two expressions with a less than or equal to, greater than or equal to, and then less than or greater than. This is the actual symbol, this is the actual statement. I don't think there's any more in there, right? No. All right, let's move on. So, simple, very simple, first one. Which symbol fills the blank? Which symbol fills the blank? Some of you already looked at it. Give others a second and let's look at the problem. All it's asking you is, are you doing PEMDAS correctly, right? Bridge, help me out with this one.
It's the one on the left is greater than the one on the right.
So greater than you're saying, right? Like that?
Yeah.
How come? What do you got?
13 is greater than 11.
9 plus 4, 13, good. 16 minus 5, 11, good. Greater than. Well done. Very simple. Okay, we should know how to do something like that very easily. Move forward. Again, you notice how fast I'm trying to go through some of this stuff? How easy was that problem, right? You probably all could do that when you were in 6th grade. I'm looking around, okay? It's not a hard problem. So let's talk about some terms real quick. Sum means add. Difference means subtract. Now, difference I want to talk about before we go any further, because a lot of people mix up their terminology and they don't speak correctly. So, here's how you speak when you use the word difference. If I want to talk about this, how might I say that? How might I make that statement not saying A minus B? Not using the words A minus B. The difference between A and B. Very good. And when you indicate that, the order in which you speak is the order in which it's subtracted also. Because we all know that subtraction is not commutative. You cannot switch the order of a subtraction and say it's the same answer. You actually get the negative or the opposite of that answer. So 5 minus 3 is 2, but 3 minus 5 is not 2. It's negative 2. So again, the difference between A and B means take A minus B. Okay, our vocabulary and the way we speak is very important. I'm going to speak about this all year. For example, if I had this, I might as well say stuff like this now to kind of make sure we do it right. How would I make that statement? And be careful, because there's a common mistake if you just read it right off. Very good. It means your teacher taught you well with the word quantity or the value or the expression x plus 5 squared. Okay, you never say x plus 5 squared, because to me, I would write x plus 5 squared as this. X plus 5 squared. Okay? That's what x plus 5 squared means. This is the quantity x plus 5 squared. Or you empathize, or no, what's the word empathize? You're emphatic about it, you pause. X plus 5 squared versus x plus 5 squared. You see the difference there? That's this one versus x plus 5 squared, or just quantity x plus 5 squared. Product, multiply, quotient, divide. Product, multiply, quotient, divide. The word power, okay? If we have a product and they are the same factors that are being multiplied, we have a power. Give me an example. What is something with a power? An expression that involves a power, guys, it's really easy. Come on, yeah.
X to the power of 6.
X to the 6th power, perfect. The power here is 6 because simply this means the following. X times X times X times X times X times X. So again, the definition of the word power, we need to know this vocab. Base, again, is the factor that's repeated. So what's the base in this case? X. X is the base here. And finally, exponent, the number of times the base occurs. So in this case, the exponent is simply 6. All right. Substitution principle is something that is utilized for the rest of your life in math. This is not a joke. I can't explain how many times you will utilize it, especially in science. When you get to physics, you're going to use substitution principle all the time. And all it means is that if you have one expression equal to something and another expression equal to something, you can substitute them in for each other and set them equal to one another. So if, let's see, gentlemen, all 5 of you stand up real quick. Let's see if this works. I'm looking at your heights and trying to see. Oh, we're close. This almost works. All right, Tristan down, George down. The 3 of you are very close in height, right? Pretty close, I'd say. So if the 2 of you are equal in height, and the 2 of you are equal in height, what can we conclude, obviously? That the last 2 of you are also equal in height. That's all, good, thank you. That's all we're saying by this. So if an expression is equivalent to something else, you can replace that something else later on. So we see this all the time, like y equals 2x plus 7, and then 2x plus 5y equals 9. What can you do? You can take this expression and
You plug it in on y.
okay, and substitute because of the substitution principle. Although it sounds stupid, it's common sense, right? You guys know this by now. But that's what it's called, substitution principle. All right, PEMDAS, we know this one right away. Parentheses, exponent, multiplication, division, reduction, subtraction. Why did I leave little gaps? Why did I change the box arrangement? Look at the arrangement. Who can explain that arrangement? There's a reason I did this. Parentheses has its own box. Exponent, its own box. But then you see that there's a box for the next 2 each. George Brown, what do you got?
Multiplication, it's
From left to right. And let's discuss that if nobody, or if people are confused by that. Same thing here, I'm not writing it twice. Be quick with your notes. That's how you don't write things twice, right? Use quotes. Whenever taking notes, don't write things twice. Just use quotes, especially when you get to college. I'm looking around. Some of you are so meticulous, which is awesome. But just wait until your teacher speaks like 5 times as fast as me, and it's all calculus, and he's just reading stuff, and you're trying to keep up. So make sure you use a lot of shorthand with your notes, please. Okay, so left to right for both of those. What does that mean? Hannah, you had a hand up too, right? So what does left to right mean?
That means when you're reading it, you want to write to either multiplication or division first, depending on which comes first.
Yeah, but depending on which one appears first, right? All right, let's simplify. Actually, let's make this even better. Hold on. Let's simplify. I mean, in this case also, you could say find the value of the expression, because you are simplifying and finding a value of this expression. Take a look at the first line. If you didn't get that, please ask. Figure out what you did wrong. Obviously, parentheses, sorry, here. And exponent is done simultaneously. That's fine. Because they appear in separate spots. You can do them simultaneously. Then I go to multiplication and division, and I go left to right. So I have to do what first? What first? Come on. We're trying to get it quickly. What is it?
4 times 11.
4 times 11 first. Because I look left to right, and I go, and I search, and I go, okay, let's see. Here, let's use a fun one. Let's use the lightsaber today. So, I look from left to right, and I see here, the 25 is being added. And I know addition comes after multiplication and division. So let's go to multiplication. That appears first on the left. And then we'll take that answer and divide it. And then we'll take that answer and multiply it. And then we'll take that whole answer and add 25 because addition comes after. So we have 44 divided by 2 times 7. This is 22 times 7. 154. 154? Always check my mental math. You never know. And then we got the 25 carrying down. So we got what? 179. Take a look at the simplification. Make sure you get the same answer. So again, multiplication division occurred 3 times from left to right. Do the first one on the left, simplify. The next one, simplify. And finally the last one, simplify. Then add 25. Questions on this? All good? Okay. Again, remember, I can't read your mind, so make sure you're advocating. Sometimes I see it looks like a little bit of confusion at times.
Can you go back and just?
Yeah. Evaluate, please. Again, this should not be difficult. This is no more difficult than the one we just did, so. Actually, while you do that, I'll be back in 2 seconds. You ready? Your answer?
Okay.
Show the word flash, okay? So we start with parentheses, the dash is in there. And we go to the exponent, 3 cubed. 3 cubed is 27. She does 27 divided by 9 all in one step to get 3 here. So she's doing 27 divided by 9 to get 3. Carries down the rest. She then says 3 minus 18. Well, that's going to give me negative 15. Negative 15 plus 12 is going to give me negative 3. Okay, check your work real quick. First simplification comes here. The next is simplifying 3 cubed is 27. 27 divided by 9 is 3. And then she goes ahead and just goes right across, left to right, to get her answer. Okay, nice, very good. Let's go to the next one. We're going to talk about quickly a term for variable. Again, you know this. It's simply a symbol. Now, it's usually a letter used to represent or be a placeholder in that domain of the variable. Okay? The set itself of all the numbers that the variable could take on is called its domain. And we'll talk about the word domain as the year progresses too. So for this one, let's evaluate. Very simple. If x is 7, y is 6, and z is 3, determine the value or evaluate the expression below. And again, this is like, I'd say, an easy level problem. Easy, I'd say, on an SAT. And all you're using is substitution principle. Check your work when you're done, please. Yeah, that's a tough one. Use common fractions instead. Common denominator. Guys, do common denominators, please. Don't convert to don't convert to decimals. It's an easy denominator to see. You need to have your fraction skills down pat. Too many students use calculators to get decimals, right? And it's fine with numbers, really. But the minute you get to variables, you can't do that. A over the quantity B plus C needs to have a common denominator to be added to another value because there's no numbers there for another expression. Okay, the answer is 6. You get 36 over 6. 10 over 6 plus 26 over 6. 26 over 6 comes from the fact that 13 over 3 multiplied by 2 over 2 gives you 26 over 6. Why am I allowed to multiply by 2 over 2? Why am I allowed to do that?
You're allowed to do it because you're doing it to the numerator and the denominator.
But why am I allowed to do it to the numerator and denominator? You're just telling me that I'm doing it to both. Why am I allowed to?
That's the same ratio between the numerator and denominator.
Okay, it remains the same ratio. 26 over 6 is the same ratio as 13 over 3. Very good. Good answer. What else?
Because 2 over 2 equals 1.
2 over 2 is 1. Yeah, and the identity property of multiplication tells me that anything times 1 is itself. So it doesn't change the value. But exactly as you said, Luke, right? Luke? As Luke said, this ratio is identical. It's just simplified. You make this lowest terms, you get this. So absolutely, good answer. I didn't even go to that answer. I thought of 2 over 2 is just 1. Both answers are correct. Yeah. Yeah, when 2 over 2 is just 1, it keeps the value the same. But that was a good way to put it, Luke. The ratio is the same. All right, this one's kind of tricky. Let's see how many we can get. I'll give you a challenge. Let's see if we can get like 6. If we can get 6, I'll be happy about that. You got one already? Go ahead. You have to. Now here's the challenge, by the way. I write what you speak, so you need to speak correctly. Do you follow what I'm saying? You have to use the word quantity or to the power of. So you need to say things correctly, and and I'll write exactly what you say. So again, you're using 5 2's to write an expression who simplifies to 7. 5 2's. You got one of them, George? Good. Give me one.
I got 2 over 2 plus 2 plus 2 plus 2.
That works. You might have the same one. That's fine. 2 plus 2 plus 2 plus 1 is 7. And how many 2's did he use? 5. You could use powers if you want. You could use...
Wait, if you use power of 2, that counts as 2, so...
Correct. 2 to the second is 2 2's. If you've got one, just raise your hand. Go.
2 over 2 plus 2 squared plus 2.
Nice. And there's so many obvious possibilities now when you start thinking about using powers also.
22 over 2.
Love it. I didn't even think about that one. That's awesome. 5 2's. 1, 2, 3, 4, 5. Never said that has to be the number 2. Just said 5 2's. 11 minus 4. What can you obviously vary that into then? Come on, using this, you can just change one thing and make another one. Okay? Minus 2 squared. That's why I was saying, once you start using the powers, you realize that there are a lot of possibilities. Now, let's say for the sake of this, 2 times 2, well, that works too, I guess. I mean, you could put a minus in parentheses and then put a plus sign there, right? So you could do it again. Anything that has minus, you can write like this. That works also. So do you see how there are so many possibilities for something like this? George, what do you got?
2 cubed.
2 cubed. You can't use a 3, George?
Yeah, wait.
Can't use it. I guess it didn't say you couldn't use a 3.
And then...
Wait, does it say only 2's? Hold on, let's see the rules.
Yeah.
Oh, it doesn't.
Okay, I'll accept it.
2 cubed and then negative 2 over negative 2.
What do you mean negative? Where's that going?
Like plus, like after.
Plus?
Yeah,
Yeah,
plus.
it's a
Plus
positive.
negative 2 over 2. Yeah, that's it.
You have to use 5 2's.
I got the 3 and the 3 2's in the house.
Oh, that's not... No, it means then... I guess if you think of... All right, so then do this, George. We could do that. That works.
2 times 2 times 2.
Exactly. Does that work? And instead of a plus a negative, why'd you say plus a negative, George?
Wait, plus negative? Oh, I feel like plus negative 2 over 2. I
Why don't you just write it like that, right?
Yeah.
Plus negative means minus. That's why minus was invented.
Yeah.
Okay,
All right.
I got one.
What do you got? Go ahead.
2 plus 2 plus 2 plus 2 plus 2 plus 2.
Too many 2's.
No, but it didn't say use only 5 2. It
says just use 5 twos. It doesn't say use only 5 twos.
All right, now we're getting into technicalities. How many do we
Yeah,
get? One,
yeah,
two,
a
three,
six.
4, 5,
6 twos.
6.
Minus 12 plus 7.
All right, now we're just adding random numbers to make it work. Thanks, Koenig. I like the idea though. Okay, good. Thinking outside the box. We got a lot of different options here. Just something to make you think. Okay, nothing that's difficult. All right, for the sake of time, since there's only a couple minutes left, I'm not going to start anything new. But